So as we mentioned, today's session, we're going to take a look at an introduction to machine learning in Power BI. Okay, so quick show of hands for everybody that's here in the room. Hopefully the majority of you, but has everybody here used Power BI before? Excellent. Keep your hands up if you've done any machine learning in either Power BI or Python. Okay, fantastic. So quite a few people are going to learn something here today, and feel free to engage with us in the chat as well and let us know your Power BI journey so far. Okay, so I'll give a very brief introduction to myself, as Alex already gave me a fantastic introduction. So my name is Leon Gordon. I'm a current Microsoft Data Platform MVP. You can feel free to scan the QR code that will now allow you to connect with me on LinkedIn, where I'm fairly active, and I do like to share little tidbits of information, generally around Power BI, machine learning, and data science in general. As Alex already mentioned, I'm also the founder of the Microsoft Power BI UK user group. We're a virtual-only user group, and we have nearly weekly sessions of Microsoft webinars where we come together as a community to learn more about Power BI. Outside of that, we also have the Data DNA Dataset Visualization Group and Challenge, which is a monthly challenge whereby we give you a free dataset you can take away and have the opportunity to win up to $400 worth of Amazon vouchers every month. Okay, it's free to enter, and we have quite an active community there as well. I'm also an official member of the Forbes Technological Council, whereby I contribute with really about monthly articles on data science, and such topics. Okay, with that being said, what will we cover in today's session? So first and foremost, we'll take a look at what is machine learning, often referred to as ML. We'll then take a look at how we can benefit from machine learning in Power BI, and we'll see how we can create a machine learning model in Power BI Premium, or Premium per User, often referred to as PPU. And then I'll then go on to show you how you can do this in Power BI for free or in Pro as well using Python, okay? And I'll give you some resources to continue learning at the end of today's session as well. So with that being said, let me give you a few caveats. We are obviously quite time constrained today. There were a lot of the more technical aspects of today's session, so I'm going to gloss over, but feel free to come and talk to me at the end if you want to know any more information. Okay. So with that being said, first and foremost, what is machine learning? So machine learning is a branch of artificial intelligence, often referred to as AI, that teaches computers to do what comes naturally to humans and animals, which is to learn from experience. Okay, machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. So the keys that I want you to take away from here is that we're looking to make the computer learn from experience, and to do so by learning information directly from data. Okay. So with that being said, how can we benefit from machine learning in Power BI? Well, we can do real-time predictions like customer churn analysis. We can predict customer leads and conversion, and we can also look to predict fraud. Now, in today's scenario, we're going to focus on the second point, okay? We're going to look at predicting customer sales leads and their likelihood to convert for an organization. Okay. So what I'm going to do is give you a fictional business problem. Okay. So the problem is that we have an organization that currently spends £3 million per year on purchasing leads. They go through their sales funnel, so through a sales call, a follow-up call, ultimately a conversion ending with a sale. Now, as we can see down here, their conversion rate is relatively low with a 4.3% conversion rate. So the problem here is actually twofold. First and foremost, we have quite a large lead spend, which is not generating a lot of sales, therefore not converting at a high percentage. So wouldn't it be fantastic if for this organization, we could actually lower the lead spend by targeting leads that are more likely to actually convert, and ultimately push that conversion rate higher by, like I say, predicting those leads that are more likely to become a buyer with our organization. In turn, hopefully pushing up our revenue numbers as well. So with that being said, let's take a look at how we can use machine learning in Power BI. We're going to go into our demos now, so please do feel free to jump in with any questions throughout. Like I say, we will cover this at quite a bit of pace, okay? So let's make the machine learn, and don't worry, although this robot looks fairly bored, no machines were actually harmed in the making of today's demo. Okay. So let's jump over, and first and foremost, we'll take a look at our data. Hopefully our monitor is going to play ball. Okay, no signal. Let me just reconnect our monitor again. excellent. It should be extending our display as opposed to duplicating it. So again, sorry for those in the room, let's just go ahead and make sure this is duplicating our display. Okay, excellent. Right, perfect. So again, I'll give you the link to this GitHub repo towards the end of today's session so you can follow on in the future if you'd like to. So first and foremost, let's take a look at our fictional organization. And to get started, we need to have two data sets, okay? One we're going to look at is going to be our prospective buyer CSV, and this is going to be our lead data. So individuals that we haven't seen as a customer before, okay? Secondly, we're going to look at our sales training data. Okay. Now, whenever you get started in building out machine learning models, you need to actually have some data to train your machine learning model with to base those predictions on. So this is going to be historic customer data. Okay. So first and foremost, let's take a quick look through our lead data. So as you'll see, within this data set, it comes from a transactional system. So we have two keys, a prospective buyer key and an alternate key. And then we have some of our customer attributes, like a customer first name, last name, age, marital status, their gender, yearly income, total amount of children, the number of children at home, their education, occupation, whether or not they're a homeowner, the number of cars they own, their city, their state province code, and also their postal code. Okay, so relatively complete set of data for our leads. Okay, now in our second data set, which is our training data, you'll see that we have a lot of common attributes like age, marital status, gender, so on and so forth. But what you'll notice at the end here is our additional column, which is a Boolean column, which represents whether or not an individual was actually a buyer for us or not. So this is our most important column because we're going to use this to base our predictions from. Okay, so with that being said, let's head over into Power BI. I'm going to use a premium per user workspace for this demonstration, our sandbox workspace. Okay. And what we want to do to get started first and foremost is actually ingest that data using a data flow. Okay. So to do so, let's go ahead and go to new, and we can say data flow. Now, those of you that are familiar, Microsoft has recently released the data marts, so they're going to try and prompt us to use those. We don't want to use those in this scenario, so we'll go ahead and create a data flow. Okay. Just while that loads, I'll go back to our GitHub repo, and I'll just open up the raw versions of these CSV files, and I'll show you why as we go back in a moment. Okay, so excellent. We've now got the nice friendly UI available to us in the service to start building out a data flow. So to do so, let's go ahead and add new tables. Okay, and then we'll be presented with Power Query Online. Nice familiar Power Query where we can start to choose our data source. Now, for today's scenario, we want to use the text to CSV data source connector. Okay. And then we just want to go back to our raw version of the CSV. Now you'll notice that when we clicked on the raw version, it now gives us exactly that, the raw version of our data. So we can go ahead and copy and paste this URL directly out of here, back into our Power Query as our file path or URL, and go ahead and select next. Now, what will happen here, with those of you that are familiar with Power Query, it will just pass that data and start to present to us back a preview of, I believe it's the first 200 rows of that data. And we can see that correctly Power Query Online has identified that our first row is actually headers, and it started to give us some data types that we can start to see here at the top left. So in this example, we don't need to make any more changes or transform our data. We can go ahead and load this table. Okay. So let's go ahead and for the time being, select save and close. Now, what will happen in the service is it will ask us if we want to set a refresh schedule. For today's demonstration, we don't want to, but we do want to give it a name. So let's go ahead with ML Manchester. Always be kind to your colleagues and yourself in the future by leaving yourself a description. I don't have any colleagues here today, but hopefully I have a future self. So I'm just going to say ML Manchester, but obviously be as descriptive as possible as you can when creating these types of objects. Okay. Like I mentioned, we will be prompted to see if we'd like to refresh. We don't want to for the time being, so let's go ahead and close. And we now have our sales training metadata within our data flow. Okay, so next we want to actually add our lead data. So to do so, we're going to go to add tables at the top here. And we're actually going to follow this exactly the same process. Okay, so we're going to go ahead and use our text CSV connector. Go ahead and get the raw version of our data set. Go ahead and paste that into our connection settings and go ahead and select next. Now, as I mentioned, once again, Power Query Online will just pass that data set, present back to us a preview of the first 200 rows. And as you can see, like I mentioned, it's identified that the first row is actually headers and our data types as well. So let's go ahead, select Transform Data and save and close. Power Query Online or the server or Power BI service even being as efficient as it is will once again ask us if we want to refresh and we don't want to for the purpose of today's session. Okay, excellent. So within those few clicks, we now have our sales training metadata and our prospective buyer metadata available to us within our data flow in Power BI service. So following along at the top here, we can see we have tables. And we also have machine learning models. So let's go ahead and select machine learning models. And next we'll be presented with a nice wizard and UI walkthrough of how we're going to create our first machine learning model. So as it mentions here, we're going to first and foremost create and train our model. And we're going to do this by selecting our training data, choosing a model type, before ultimately training our model. Once we've done that, we're then going to look at ways that we can improve our model, okay, by iterating and retraining over the data. And then finally, we're actually going to apply our model to our lead data and get our predictions back, okay. So let's go ahead and get started. Like I say, doing it this way, we're going to be walked through a nice UI wizard. And first and foremost, it's going to ask us what we would like to predict. Now, as I mentioned at the top end of today's session, we want to predict whether our training data will become a buyer or not. So the column that we're actually looking for is our buyer column, okay? And this comes from our sales training table. So once we've selected those values, we can go ahead and select next. Now, once again, in the background, Power BI is passing that data that's being presented to it, and it's actually recommended to us a prediction model, as we can see here on the left-hand side. So as it mentions, based on the column we've selected, we've recommended us a prediction model. The model learns from our data to predict whether or not an outcome will be achieved. And in this instance, it's actually based the correct prediction, which is the binary prediction. So as I mentioned, predicting the outcome of whether whether an outcome will be achieved or not. Okay. If this wasn't correct, we could go and select a different model here. And as you can see, we'll be presented with both classification types of model and regression as well. So as I mentioned, binary prediction is correct, predicting whether or not an outcome will be achieved. But ultimately, we could have used general classification, which distinguishes between 2 or 3 outcomes. This is generally used for credit card applications and grouping those into individuals that have good credit, bad credit, or require a little bit more further analysis. And my favorite is regression, which is estimating a numeric value. And this is generally used for estimating house prices, okay? So as I mentioned, binary prediction is the correct model for today's session. So let's go ahead and reselect that. And then we get to select a target outcome. Now, as we mentioned, we want to understand whether or not an individual will become a buyer or not. So we're looking for that value to be true. When we get a match on our prediction, let's call it a buyer. And when we get a mismatch, let's call it not buyer. Okay, go ahead and select next. Once again, in the background, Power BI in the service will just pass the data presented to it. And it's actually going to recommend to us columns within our data set that it feels has the high correlation with the outcome of an individual becoming a buyer. Okay, now in machine learning, we actually refer to these columns or attributes as features. So from this moment forward, I'll be referring to these as features, okay? So you can see on the left-hand side here, the Power BI has not recommended all of the features to us to be selected for the reason that it believes we have a low correlation with the outcome of it being a buyer. Now, me being as likeway inclined as I am, is I like to invoke a little bit of chaos. So I'm just going to select those that Power BI has not recommended to us, okay? And you'll see why as we go through. So let's go ahead and select next. And then let's give our model a name. So for the purposes of today, let's call it ML Manchester. As always, be kind to your future self and your colleagues and leave yourself a description. Again, ML Manchester. And then we have the opportunity to set a training time for our model. Now, I don't know about yourselves, but whenever I train on something, or I like to think anyway, whenever I practice something for a long period of time, I tend to think that I'll get better the more that I do it. And the same is true for our machine learning model. The longer we give the machine learning model time to train, the better the predictions will be. Okay. Now, Power BI offers us to train from as low as 5 minutes to as much as 360 minutes. Now, as I know that there's football on this evening and we've all got other things to do, and Eugene wants to speak as well, I'll set this to 5 minutes. But like I say, when you're doing this in your own environments, the longer you can train, the better generally the prediction outcomes. Okay, so that's great. What will happen next? So as we can see at the bottom here, the model will actually take 80% of the data that we present to it to base its predictions on, so to iterate and train on, okay? The remaining 20% will actually be used to test those predictions against, okay? So it's going to take 80% of the data first to use to train and iterate across, and then use the following 20% of that data to test its predictions against. So let's select Save and Train, okay? Now, those of you that are familiar with refreshing data sets or data flows or even data marts now within the service will be very familiar with the fact that we now have our data flow refreshing. Okay, that, like I say, in the background, going ahead and basing those predictions off and testing that data. Okay, just while that runs, I'll pause here to ask if there's any questions either in the room or online. Yes, please. Very much dependent, A, on the size of data, and B, whatever else you have running. So this could be if you're refreshing other data models, data marts, etc., or as well if you have heavy transactions as well hitting. So it's very difficult to quantify, and what I'd recommend is either using log analytics or Phil Mark has a great solution in terms of being able to quantify what that looks like in real time as well. So hopefully that answers it. Yes, please. Yes, a great point. We're very fortunate in the fact that this data set is tailor-made for machine learning, so it is very clean. If you are going to do this in your own environment, and to be honest, this is basically the same with this is a fundamental data principle. Anything you're going to do with data is garbage in, garbage out, right? So make sure that your data is as clean as possible, is as transformed as you need it to be. This will obviously help with feature selection, as well as basing the machine learning model predictions off of. So yes, there will be differences depending on how clean your data is. Okay. Any more in the room or online? Yeah. Binary prediction, or do you mean neural networks? It will be. So what I will show you as we go through, when we go through the Python solution, is you get access to more models, random forest, etc. Power BI underneath the hood for this one, I believe, uses the binary regression model for this one, based on neural networks. Okay. So basically, just to put that into context as well, the ML you're running in Power BI on a data flow is the same as AutoML. Okay, so the only difference is you're doing it in the Power BI service as opposed to doing it in your Azure environment. Okay, excellent. So to keep this moving forward, I'm going to go on to a previously deployed version of this data flow, aptly named ML Webinar Deployed. Okay, and we'll pick it up from where you will end off once your machine learning model is deployed and you've gone back into your data flow. Okay, if you head back over to machine learning models, you'll now have this icon readily available for you, which is to view the training report. Okay, by selecting this, you'll be presented with a report on how your machine learning model trained. Now, sometimes this takes a few seconds to generate in the service, so I've gone ahead and preloaded this ahead of today's session because I know we're up against it with time. So we get 3 tabs within this training report. And again, I'm going to gloss over a lot of these aspects that I don't think are relevant for an introductory session, but feel free to go and deep dive, and I will give you some resources as well to continue from Microsoft that will show you some more insight. Okay, so first and foremost, we're going to take a look at model performance. So this is how our model performed going through its predictions. Now, the first metric to be aware of is the AUC, so the area under the curve. Again, anything between 7 and 10 or 70% and 100% is basically a good run. Okay, so that's where to aim for. The higher, the better. But generally, between 70% and 100, you're in a good position. So let's go ahead and see our top predictors. Now, this small snapshot visual here will give you some insight into why, when I have invoked chaos, Power BI was actually right in not recommending those features because they have a low correlation. You'll start to see them here with yearly income, total children, so on and so forth. And we can see that the features that give us our top predictors of the outcome of a buyer by influence, first being age. Okay, and by clicking into this bar here, we can start to see any patterns that are emerging within our data. So, for example, for this fictional organization, we can see that our buyers are generally 46 years old and less, or 46 to 59. So, in theory, 59 years and younger. Okay, their marital status is single. Okay, the total children they have at home is 1. And so on and so forth. Okay, so you can see there that Power BI was actually correct in the features that it presented to us to use. Okay. Now I will just go into this matrix here in a very slight bit of detail. Okay, this is what's known as a confusion matrix, and I'm going to try not to confuse you here. Okay, and the best way to do it is to look at the top left. The top left cell is a true positive. So this is where the machine learning model has successfully predicted that the outcome would be true. And in the bottom right is a true negative. This is where our machine learning model has successfully predicted that the outcome would be false. Okay, we then have a false positive and a false negative in the 2 remaining cells. Okay, so the one that we're most interested in for today's session is the value in the top left, a true prediction that our individual will become a buyer. So as we can see in our report, we've actually performed relatively well in the fact that the amount of values that have been predicted correctly as a buyer, but we've not performed well at all in the fact that we haven't correctly predicted any outcomes where an individual will not be a buyer. Okay. Now we have something available to us which is called recall and precision. This outweighs the purpose of today's session, so I'll just show you what happens to our confusion matrix when we increase precision. Okay, you'll see that we now have more correct predictions for a true negative and less for a true positive. Okay, a good starting point is around 0.5. Okay. And like I say, you can increase your recall or precision based on your requirement. Okay. So let's go into our accuracy report, as we can see at the bottom tab here. Again, very much going to gloss over. What we're looking for here is our visualization in the bottom left. Okay, so at the top we have our teal line, which is what would be an ideal guess. Okay, this would be perfect, pretty much in terms of a guess. Okay, what we have at the bottom in our black dotted line, what would be a random guess. Okay. And then we have how our model performs. So we can see that our model's performing relatively in the middle of both an ideal and a random guess. Okay. And then finally, on our last tab, we have some training details. Now, this goes into a bit more insight in terms of the final model being used, the amount of iterations that were run against the model, and then the performance of the model quality over those iterations. As I mentioned, you'll start to see if this went on for longer, the predictions, the quality of the iterations to be higher. Okay. That being said, we now have our machine learning model complete. So we can go ahead and apply this model's predictions by using our apply model button up here. and we can apply this model to our lead data. So to do so, we would go ahead and select our prospective buyer table as our input table. We would give our outcome column a name, so let's call it outcome. We've already set our threshold between precision and recall to be 0.5. And if you are doing this in your own environment, go ahead and select save and apply. Okay, I've already run this, so there's no need to go ahead and save and apply. So let's cancel, and I'll go ahead and show you the outcome once you've applied that model. Okay. So now when we go back to our tables, which is where you'll be presented by when you've applied that data, we started off with 2 tables, okay? Our sales training data and our lead data. We now have 6 tables. So we have that buyer prediction training data, that 80% of data that the model used to train and iterate over. We then have our testing data set, which was that 20% of the data set to use to test. And then we have the data set that we're most interested in, which is our enriched buyer prediction data set. This is actually our lead data, so our prospective buyer data with the new outcome prediction column applied to it. Finally, we have some explanations in terms of why the model has predicted what it has. So now we're in a position to go ahead and connect directly to that data. So to do so, let's fire up a new Power BI report. Okay. Hopefully the Wi-Fi holds up pretty well. In here, there's been some testing times in terms of Wi-Fi holding out. This data set's relatively small. We're talking a couple of megabytes, but you'll be surprised how badly that can load on Wi-Fi sometimes. Okay, let's go ahead and get data. And then what we're going to want to do is connect to our sandbox environment. Excellent. So we've been presented with our get data wizard. We can go ahead and input data flows. Okay, we want to use the data flows connector. Go ahead and select connect. Hopefully the joys of using multiple accounts means I won't have to log in again. So fingers crossed. I did log in before today's session, so hopefully that stays true, which it looks like it has. We can go over to workspaces. Load our sandbox workspace. Then we'll be looking for, in this example, our previously deployed webinar data flow. And then we want our buyer prediction, our prospective buyer enriched buyer prediction table. Okay. Now, what I'm going to do, just so we don't have to wait around and with the data in Power Query, is just load that data directly so you can see the outcome. Okay. And then we'll go on to show how this solves the business problem. Okay. And I think we're all very familiar with waiting for Power BI to load data for us in this moment that we're in here. Okay, fantastic. So we've now loaded our data. I'll just give you a brief insight by going into the data view. So you will notice that this is our lead data as we have our prospective buyer key, our alternate key, first name, last name, so on and so forth. If we scroll to the end now, we now have 4 additional columns, okay? And they have the buyer prediction either schema or prefix, depending on how you want to name that. So we now have our outcome column. So this is our machine learning model's prediction on whether or not these individuals will become buyers in the future, okay? We have a prediction score also. Now this is the weighting from 0 to 100 in terms of the accuracy of that prediction. The higher and closer to 100, the more accurate, and the lower, the less accurate. Then we have 2 columns that we're not really too interested in from a reporting perspective. This is the explanation in terms of why the model predicted what it did. And then we have an index for that explanation as well at the end. Okay, so let's go ahead and load this data up. So for the purposes of this, let's get our lead's first name. and last name. And this is not a visualization session, so please don't judge me, okay? And let's go ahead and get their outcome column and their prediction score. Okay, just in a rudimentary table. Excellent. Let's take off. So what you may notice is that it's pre-aggregated. So let's go to don't summarize for our prediction score. And then what we can do is have a very rudimentary slicer. So let's just use our prediction outcome as our slicer. And let's select those that our machine learning model predicts will be buyers with us by selecting true. Let's list by our prediction score descending. Okay, and now what we have is a list of leads that our machine learning model predicts will actually become buyers for us in the future. Now, this is fantastic. We can give this to our sales team and say, go ahead, have fun. These are more likely to convert for us. Okay. Ultimately, we can do the same for those individuals that are false, that are less likely to convert, and either say, okay, we don't want to actually purchase these types of profiles anymore, or just not call these until after we've already gone through those that should convert for us. So that's how we can successfully predict if an individual will become a buyer for us for sales lead conversion. Okay, that's fantastic, and that's really, really good if we have Power BI Premium or Premium per user. But what happens if we don't? Okay, yes, PowerPoint is playing ball. Great. Okay, so if we don't, we do have another approach available to us. Now, this is a very, very much more technical approach, so I'm going to go through this very, very quickly in an effort to stay on time. Okay, and there are limitations to this approach. So we don't have any machine learning ops available to us, which is referred to as ML ops. We only have the personal gateway available to us in the Power BI service. It becomes very difficult to manage dependencies, and we can't scale this version. Okay, so this is very much an art of the possible. To do this, we need to have some alternative tools. Okay, first and foremost, we need to have Anaconda. Now, if you're looking to get started with data science or Python and R, Anaconda is by far the easiest way to get up and running, in my opinion. And then we're going to use a open source library called PyCarrot, made by a gentleman called Moez Ali in Python to base our machine learning off. If anybody wants access to the GitHub repo, the QR code is on the screen now, so please do feel free to scan. Ultimately, if not, you can come and see me after the session as well to grab that. I'll just give a couple of moments for those that do want to scan at the moment. No pressure, no pressure. Everyone's trying to find the camera as quickly as possible. But like I say, we will come back to this after as well, okay? Perfect, thank you. Okay, so let's go into our second demo. Okay, so to get started with this demo, just thinking about it, are we back up and running? Joys of PowerPoint. Let's see if we can continue without crashing. Okay, the joys is, so for those of you that are here with us in person, so I've actually driven up from Milton Keynes the 3 hours to get here. I'm going to be driving back after this session, the 3 hours to get back. And I'm doing the same session in Italy, leaving tomorrow on Saturday. So hopefully we can iron out some of these connection difficulties as we go forward. So with that being said, to get started with this version, let's go ahead and start up a new Power BI desktop file. So we've got that out of the way. And then what you want to do in your environment is go ahead and download Anaconda. Anaconda is freely available for personal use, so go ahead and get that from anaconda.com, and you can install that on your machine. What you may find is that you may need to also install the Microsoft C++ build tools. It's a MSVC compiler, some libraries and scripts. So if you do encounter any errors, then just go ahead and get the C++ build tools and you'll be fine. Okay, so once you have Anaconda installed, what you want to do is fire up something called the Anaconda command prompt. Okay. Now, whilst this looks like we're getting slightly more technical, to be honest, we are, but we're really going to put in 3 lines of code for this purpose anyway. Okay, so when you fire up the command prompt, you'll notice that we're actually in what's called a base environment. This environment is a container or a folder, for lack of a better term. Okay, and what we want to do, or for the purposes of today, I've created a new environment, so we've got this in its own silo. So to do so, we can go ahead and use the activate keyword, and we're going to use the environment data science _ UG. Okay, now what you'll notice is that we've now flipped over from our base environment to our new data science _ UG environment. Now, when we're in that environment, we need to install what's known as pip. Now, pip is a package manager within Python. So to do so in Anaconda, we just use the conda command, the install command, and then pip. Okay. Now, this requirement, pip is already installed on this system, so it should run through very quickly unless it requires an update. Okay. It's always going to be the way that it will require an update when we come to demo. So just bear with us a couple of seconds. Okay. Once we've installed pip, as I mentioned, is going to be our package manager. So once we've actually installed our package manager, we can go ahead and install the library that we're most interested in, which is PyCaret. Okay. So this will go through and just run a few commands. Like I say, this requirement is already set on this system, so it should just take a couple of seconds. In your environment, when you are doing this, obviously for the first time, it will take slightly longer. Okay. Okay. And I'll give that a second to run. Yes, we do have an update available. So let's go ahead and select no if we can. Okay, it's BS to the punch. So if you do update in the future, then you'll see what it looks like when it's running through for an update. And we now have the latest version of pip installed on our system, even if we didn't want it at this moment in time. So with that being said, we can now go ahead and install PyCaret. So to do so, we just use the command pip install PyCaret. Okay. Again, that will go ahead and hopefully satisfy the requirement on this system because it's already installed. And then within 3 lines and about 9 keywords, give or take, we then have our Python environment set up and ready to do some machine learning in. Okay, which is great. But Power BI has no idea where this environment is. So to make Power BI aware, and I'll just jump across because the requirement's already satisfied here. So to make Power BI aware, let's go ahead and select cancel. We can go into our options and settings, go into options, and then what you'll notice in our global options is that we have the Python scripting options available to us. Okay, so just in our global options here, we have Python scripting. We want to go ahead and set our detected Python home directories to other. We want to go to our Anaconda install and browse for our environment that we've just created. Okay, bless you. And then we want to go ahead and select OK. Now, once we've selected OK, Power BI is now aware of our Python environment, and we can start using all of those packages that we install in that environment directly within Power BI. So let's go ahead and get data. And in this example, we want to get data, but we want to get data from the web as opposed to text CSV. Okay, let's go ahead and select our web connector. Now, what I'll do, I know we started slightly late, but what I'll do in effort to stay on time is just show you the nuances between the 2 different approaches, and then I'll go to a pre-cooked version of it so you can see the outcome. Okay, so we want to, again, put our URLs across from our Git repo, the raw URLs, and then go ahead and select OK. Just make sure I didn't paste twice. Okay, perfect. And then select OK. Now, what you'll notice is that Power BI Desktop lags behind Power Query Online. Sorry, let me rephrase that. Power Query in the desktop lags behind Power Query Online. So our first row hasn't been correctly defined as headers, and our data types haven't been defined either. So we do have a few manual transformations to do here, and it's the same for both data sets. Okay, so for those of you that haven't done it before, either in the room or online, you can just use first row headers up here in the transform settings, and you'll notice that our first row jumps to our headers. And ultimately, the quick way to set data types for those that don't like to use M or are not familiar with M is to just change them using the left top hand corner here, and you'll see that our applied steps and transformations are applied on the right hand side. Okay, You'll need to do that for both data sets when working in Power BI Desktop, and that's as far as I'm going to go with this portion of the new version. Let's go ahead and go to our pre-cooked version and pick up from a very similar point. So let's go ahead to our training data. So sales training, and I'll go back into our Power Query. Okay. And pick it back up from where we changed our types, okay? So once we've changed our data types, we want to go ahead and use the transform menu item to run a Python script, okay? You'll notice it up here on the top right. And what you can do, once you load run Python script, we get presented with a very, very, very rudimentary IDE, for lack of a better term, or a window, whereby we can paste in or write our Python script. Fortunately, if you are following along and you go back to our GitHub repo, I've laid out all of the Python scripts for you. So you'll see there 1, 2, 3, and 4. And you start at 1. I'll open this up in a new tab. Let's do it looking this way. I'll open each of these up in a new tab just to save on time. Okay. Let's go with, okay, so our first Python script, again, without getting too technical, you can just go ahead, copy that out, paste it directly into your IDE, select OK, and it will present back to you, those of you that are familiar with Python, any data frames that you've built in Python will be made available to you in Power Query. The one that we're interested in is df_imputed, so we'll expand this table here, okay, and you'll be presented back with the result set. Now, what you'll see that we've changed here is we've actually, for lack of a better term, mapped our distinct values to decimal values here. So the gender column is a good example of this. In this data set, we only have male and female as the genders. You can quite clearly see that we have 1.0 and 0.0 now to define those two distinct values. And it's the same for all of our feature columns. Now, the reason to do this is we need to be using decimal values with PyCaret. We can't be using strings or text values with the library, okay? Once we're in that position, we can go ahead and run our second Python script by selecting Run Python Script up here, okay? And then what we're doing in this Python script, and again, this is available to you in the GitHub under Python script 2, okay? This Python script, again, without getting too technical, is recreating everything that we went through in the service for training our machine learning model, but we're now doing it using Python as opposed to the nice UI wizard, okay? Once we've selected OK, we're then presented with a predictions table, okay? Finally, that predictions query will give you, in this instance, our sales training data, but we've applied our label and our score to our sales training data in this scenario, okay? We've now successfully run our machine learning model in Python on our data, and it outputs, for lack of a better term, a saved version of this model that we're now going to go and apply to our lead data. So we've ingested our lead data in exactly the same way, promoted our headers, so we're in a very similar point, and we're going to go ahead and run our first Python script by selecting Run Python Script up here. In the GitHub repo, we will have Python script number 3, which is doing exactly the same as what we did to our sales training data, okay? And it's imputing those values, encoding those values for every distinct value, ready for our PyCaret module, okay? So we select OK on that. Once again, we have df_imputed as our data frame. We expand that, and again, you can see quite clearly on our gender column that we have just those two values for male and female within this data set, okay? Next, we want to run our final, but arguably most powerful Python script, okay, which is number 4. And this, even though, like I said, it's very, very small, is applying those predictions to our lead data. So you go ahead and select OK on that. I'll cancel because it's already run. And then we can have our predictions table presented to us. Okay, we then, as you saw previously, we imputed all of our values, encoded them. So we have a little bit of cleanup just to get our first name and last name actually back into the data set as text. And then we can present this back. So let me just close this without applying. Okay, and then what you'll notice once we go back into this data set is we have our sales training data available to us. We can go ahead and select our, sorry, not our training data. We have our lead data available to us. We can go ahead and select our first name, our last name, our label, and our score. And also, we can have our rudimentary filter, which gives us our true and false values. So in exactly the same way that we had in Power BI Premium or Premium per user, we can start to filter out those that will buy from us or predicted to buy from us, and obviously those that won't as well. Okay. Now, just to caveat this, the way that I presented this to you today in terms of going through the individual Power Query steps is not the way that I'd recommend to do this if you do it at all in Power BI. Okay. The reason I demonstrated to you this way is that it shows you what we're doing to the data. Ultimately, you actually want to build out your own Python script outside of Power BI and call this with the the Python script connector. So to do this, once again, this will be the last part of the demo. Once again, we have the script available to us in the GitHub repo, and it's called Python end-to-end ML, aptly named. And this is a single script that does everything that we just went through. Okay, so what you want to do is go ahead and get data. I'll just show you this on this version. So get data, you'll call up the Python connector. It will present back to you, once again, our rudimentary IDE, our window. You just paste the script directly in there. Okay, hit OK. We have a single table available to us, which is predictions. And you'll notice that we get exactly the same data set back with first name, last name, label, and score in a single step and a lot quicker than all of the Power Query steps. So that would be the recommended way forward. Now, finally, just to finish off, you can see there, as I mentioned, that we've been able to recreate what we were doing in Power BI Premium or Premium per user for free in Python. Okay. On PowerPoint. Excellent. So we now have a vision. Yes, I do love Marvel. So here's how we can take it to a new level. So we can start to use outlier detection in PyCaret, potential topic distribution, association rule mining. We can go on and do house market prediction and all sorts. Okay. As I mentioned, I would give you some more resources. So a good friend of mine, fellow MVP, Lucas Zavarella, has a fantastic book called Extending Power BI with R and Python. You can also go to a website called adnuggets.com and towardsdatascience.com, which are fantastic for anybody that has an interest in data science. Anaconda.com to go ahead and get the Anaconda resources. And again, Microsoft has some fantastic resources available to us as well for machine learning. And with that being said, do we have any questions before we finish off? Okay, so we'll answer that question in a couple of ways and as quickly as possible. So Python is very badly supported by Microsoft in the Power BI service, okay? So a lot of these, so generally if that model goes to the service, it won't refresh, okay? Because PyCaret is not supported. So you can only do that way locally, which is why I said one of the caveats is that it's not scalable, okay? At the point that you start using Python, I'll question the need to use Power BI. To be honest, it becomes more of a hindrance than supporting. So once you do get familiar with Python, doing the way we went through in the wizard in the service is the easiest way to get up and running. But generally, you should be looking to go to AutoML and then onto the likes of Python and R. And at that point, you should really escape the Power BI ecosystem and go into Azure or something similar, Databricks or Synapse, etc., and just use Python or R on its own there. Okay, so the recommendation is this is the art of what's possible and giving you the fact that you can still do it without needing premium or premium per user. But the caveat is I probably won't recommend it unless you're just doing it for yourself. Yeah. Any more? Excellent. Perfect. Thank you, everybody, for your time.